my side length, my side length ratio. In this case, the side length ratio is 5 over 3. 5 over 3 is 1 over 6. So that's my ratio of side length. The example I gave you was like a classroom. If I measure one wall of classroom, I'm measuring in feet. If I measure the whole perimeter, I'm still in feet. Nothing changes when you go from side length to perimeter. The ratio stays the same. So the perimeter ratio would also be 1 over 6, meaning the small perimeter over the large perimeter would be a 1 to 6 ratio. So I'm going to find the small perimeter. 5 plus 6 is 11, plus 10 is 21. And then the large perimeter, I'll just put a P for. And then I'm going to cross multiply and solve this. 1 times P equals 21 times 6. 21 times 6 is, I'm going to draw a blank. 20 times 6 is 120, so 21 times 6 is 126. So the perimeter of the bigger triangle here would be, XYZ would be 126. So remember, side length ratio, whatever the side length ratio is, the perimeter ratio is just exactly the same. It's the area ratio that would be squared, just like if I were measuring the room in feet. The area of the room would be square feet. The volume of the room, the volume ratio, would be the cube of this. Just like if I were doing the volume of the room, it would be in cubic feet. Okay, moving along. All right, if triangles ADE and ABC shown in the figure to the right are similar, what is the value of x? Again, consider drawing them separately. Pull them apart so that you can see the lengths for themselves individually. So again, the smaller triangle, ADE, that's 3, 2, x. The bigger triangle is A, B, C. This is 12. This side over here, from B to A, looking at the picture, from B to A is 4 plus 2. So that's 6. From C to A, we don't know because we don't know from C to E. That's okay because I have enough information to find out right now what x is. I can compare 6 and 2. 2 to 6. And say that's the same as x to 12. So 2 over 6 equals x over 12. Cross multiply, we get 6x equals 24. Divide both sides by 6, and you get x is 4. And that's my answer. Number 4. You may be able to set up a proportion for this without drawing the picture, but let's look at the picture. The picture for number 4 has a 6-foot-tall person with a shadow of 1.5 feet. They are next to a flagpole that we don't know how tall it is, but it has a shadow of 5 feet. So 5 to 1.5 equals x to 6. Remember, there's lots of ways to do that. So I would say x over 6 equals 5 over 1.5. Cross multiply 1.5 equals 30. 1.5x equals 30. Divide both sides by 1.5, and you have 20. X is 20. So the height of the flagpole for number 4 is 20. Number 5, we'll come back to. Number 6, I'm going to talk about number 5 after the explanation. Number 6, consider the following diagram. We've got BCD. BCD has this info, and H doesn't have anything. BCD, H, I, there we go, sorry about that. momentarily forgot my alphabet. Okay. And then this is 30. Okay, so this is what we're given. It says if the value of x remains unknown, we can't use this because we don't know, we can't compare x and 30. We don't know them. So I might as well not even have them. If this is all we have, which angle congruence would ensure that P, this triangle up here, is similar to this triangle down here by side angle side. The angles that we have to be the angles in between the two sides. To be side angle side, the angle has to be the included angle. So my answer for part A at the bottom for number 6 is angle C would have to be congruent to angle G. In part B, this time it does not say that we have to get that, we have to leave x out of it. This time it says, what if we don't know anything about any angles? But we do know that this is x, and this is 30. What would x have to be? Well, this means I'm using side, side, side. So x over 30 has to be the same proportion as 12 over 18, so 16 over 24. So I would say x over 30 equals 12 over 18. And then cross multiply. You can actually simplify this before you cross multiply if you want to. Get that 2 over 3. Or you can just go ahead and do it as it is. And that would be 18x equals 260. Divide both sides by 8. And that gets us to 60. All right, looking at number 7. I'm sorry that number 7 is actually difficult to do really well because if you try it correctly, it's going to go off the page. So let's look at number 7, and I will walk you through this on try and draw this as correctly as possible. Yeah, that would be enough. So let's come over here. Yeah, well, it's not exactly like it. Let's put it that way. But it's enough to get the important points. Here's the important things. First of all, how you do this, the process is the following. Take a straight edge and draw a straight line connecting your center of dilation, which is P, is any point like A, and then beyond. Keep going. So remember, it's like to a point and beyond. To a point and beyond. Straight edge, to the point and beyond. It looks like this. Next, I'm going to measure the distance between P and A, or the distance between, you can measure each one by one, or do them all at once, measure the distance from the center of dilation to each of these points. Let's suppose that I get 3.1 centimeters for P to A. Then since it said that the scale factor is 2.2, I'm going to multiply that number by 2.2. Grab a calculator, I'll tell you what it is. So 3.1 times 2.2 gives me 6.82. So I take that 6.82 and then I would use my whatever measuring device I'm using, and it was 6.82 on this line, and that would give me my new A, which I would probably call A prime. Do the same thing here. From P to C, measure that distance, multiply that distance by 2.2, and then figure out how far that means you're going out here. From P to B, measure that distance, multiply by 2.2. And it's going to look a little like this. It's going to look, mine's shape's a little off. It's a little more off right now. Okay, but part of the reason I wanted to do this one first is the following. When you do a dilation, it's important to notice that every time you connect a point and its image, the line that connects them goes through the center of dilation. So the line that connects C prime and C will go through the center of P. The line that connects B prime and B goes through the center of P. So in number 5, when they ask me to find the center, that's how I do it. I do it by connecting each point and its image. Meaning, I would connect D prime and D. Draw a line that connects them. Then I would connect C prime and C. Draw a line that connects them. Then I would connect B prime and B. Draw a line that connects them. And connect A prime and A. Okay, and the center of dilation is going to be right where all those lines meet. Okay? That point, I believe, is -2, 1. All right, number 8 is kind of messed up because there's actually 4 points. Let's go ahead and name another point. And it doesn't matter if you did your letters differently from me, just make sure you have the same points. You don't have to be in the same order. So I'm going to say A, B, C, D. So the original value for A is 3, 5. B is 1, 1. C is 6, 1. D is 3, 3. Okay, so if my scale factor is 1.5, all I have to do is multiply all these numbers by 1.5. So A prime would be 4.5, 7.5. B prime would be 1.5, 1.5. C prime would be 9, 1.5. D prime would be 4.5, 4.5. All right, next, number 9, determine whether 2 rectangular prisms are similar. If so, find the scale factors. Okay, we're going to compare smallest side to smallest side, medium side to medium side, and so on. So the smallest side here is 12, and the smallest side over here is 8. So we compare 12 and 8, and see if that's the same as medium to medium would be, oops, I skipped. The medium over here is 12. So 18 to 12. And see if that's the same as 30 to 20. And the answer is yes, it is. They all reduce to 3 over 2. And so my scale factor is 3 over 2 or 2 over 3. They didn't really tell me which one was the new one, which one is the old one, so it's impossible to say it in the right order. Scale factor, usually order matters. You always put new, because the idea is it's a number that I can multiply the old one by to get the new one. Like here I have the original, I multiply that by 1.5 to get the new figure. All right, on the back here, I'm going to go ahead and tell you what these are, and then I will break it down for you. First, I want to just give you the quick version. One sec. Okay, sorry. Somebody said my key was across the room. Here are the actual, ignore what I did funky over here. A is a rhombus, B is a parallelogram, C is a trapezoid, D is a kite, E is a square, and F is a trapezoid. But you can't just give those answers. That's not sufficient. You're going to actually have to show how you know. Okay? So for instance, for a rhombus, I have to show that all 4 sides have the same length. For parallelogram, I could show the slopes opposite